Okay, this is the mission 54, organized by Space Analog Station Habitat Marte. And then during this mission, we are also discussing the facilities operating Mars and also how would be the processes to produce uh, propellant in Mars. Okay, okay. Now you are the host of the meeting, and today will be we have the presentation of Bryan Ho. Okay, Bryan.
Yes, can you guys all see my screen?
Yes.
Uh, Present. All right. So I'll be presenting today on the main station for our habitat at Habitat Mart. So a few things we're going to be talking about is just the design, the technologies used, resources, some of the org structure, different positions, training programs, and some resources and some guidelines, some protocols that I've listed out, some technologies and how it can actually impact back on Earth. And at any point, if you have any questions, feel free to hop in. So the design that I've looked at, I'm going to talk about two parts, the external and the internal. So the external design, the one design that I went with is actually called Marsha. It's made by the AI Space Factory. Now, on the right, you'll see an image. It kind of looks like almost like a vase, but this is actually a 3D printed material, and the material is similar to concrete, but it's actually a mix of a basalt fiber, which is directly um, harvested from Martian rock, as well as well as bioplastics, which we could grow on Mars. So the combination of this basalt fiber and bioplastic has actually been cited to be stronger than the traditional concrete we use day to day on Earth. So using this material, number one, there's an abundance of the material, given that a lot of the Martian rock has a basalt component to it, as well as should we be able to grow enough plants to support the bioplastics, then this won't be an issue in terms of a resource management. Um, so each so each one of the Mars stories high, and I'll show the internal design on the next slide. So starting from the top left, each top left followed by top right, bottom right. These are the stories from top to bottom. On the lowest level, what we have is you can see it's the docking port for the rover or whatever vehicle we'll be using. There's the EVA prep in a wet lab, spacesuits, space hatches, and essentially this is kind of I'd say almost like the garage leading out towards the open Martian landscape. Above that, right above that, we have the kitchen and the dry lab. And the one thing that really sold me on the Martian design is the fact that we have a sufficient amount of windows to provide natural lighting um, into the habitat. Similarly, on the third level, we've got the sanitation pod garden, and it's all run up by a spiral staircase. We have windows as well for natural lighting to promote, just good mental health as well as just lighting purposes. Sleep pods, there's four of them, and each pod will have an enclosure. So enclosure, a work desk, and a bed. So very similar to kind of like almost like a university dorm. And lastly, on the highest level, the fourth story, we have the kind of recreation center where we have gym equipment, physical activity, things to kind of keep um, the humans kind of active during their time here. So each pod can hold up to four people. And so depending on the amount of people we're looking at for a given mission, we can have multiple pods. And this obviously will be more or less um, more or less efficient because the material is 3D printed from in the Martian rock. The technologies that we'll have to bring. So to kickstart the infrastructure, we'll need to have 3D printing machinery as well as the interior equipment that we don't print. For example, things like the beds, which you wouldn't want to print out of concrete. Beds, maybe the kitchen, cooking appliances, and so forth. But the main thing is that the resources from Mars, a lot of it can be used. So the bioplastics, like I mentioned, from plants, we'll have to have a facility that can grow plants, as well as harvesting the basalt fiber. So we'll have to have, for shipping from Earth, we'll have to have methods of harvesting the basalt fiber, as well as methods to process it and filter it to our required specifications. And then also, furthermore, where we can mix the basalt fiber and the bioplastics to form the concrete. So going towards the management of the main station structure, the way that I've outlined it is very similar to how the military kind of uses it. We start with our commander, and then we'll have three individual branches. One will be the engineering lead, one will be the research component, and one will be the facilities. So the engineering lead, there'll be multiple engineers, but what I've outlined here is there's going to be a structural engineer, electrical engineer. We can have multiple engineers as the habitat grows. Under the research, I've divided into two main things. We have kind of the biophysiology, biology, more of the science researcher as well, as well as the geological researcher. And from the facilities lead, we're going to have a medical doctor, as well as we'll have anything that's any sort of technician that requires to operate the rovers, the vehicles, anything to fix the facilities, the habitat itself. Now, a bit more description about each one of the positions. The commander, the job of the commander ultimately is to oversee the success of the mission and the well-being of the crew. Now, the commander will be the most experienced in terms of whether it's operational experience as well as technical expertise. Preferably, he'll have a military or leadership background, like a senior officer or a general of some sorts. Now, each one of the other leads, the engineer, research, and the facilities lead, their primary goal is to oversee a small team and oversee their work, their progress, and their well-being. Generally, these will also be experienced members, people who are in their mid-careers, and preferably they'll all have advanced degrees in their respective disciplines. For engineers, we're talking about master's, PhDs. For researchers, same thing. Facilities lead, perhaps for the medical doctor, you'll have a medical doctorate. You'll have, it could be like an optometrist, dentist, and for the lead and for the technicians, maybe like an aircraft maintenance engineer, any sort of degree or certification in the respective fields. Breaking further down in the tree, we have the engineers, and to name it, looking at leading new habitat options, looking at improving them as well as maintaining them. Electrical is the lead for the power solutions for the habitat. For the researchers, for the bioresearcher, there's kind of multidisciplinary in terms of leading both the psychological and physiological experiments, looking at human factors as well. Geological researchers are going to be leading the EVAs as well as looking at Mars rock sampling and research related to the geology of Mars. In the facilities branch, we have the medical doctor, which is obviously the point of contact for any physiological issues, who will also be working with the bioresearcher for physiological experiments. And I guess the technicians, they'll be assisting all the issues with the vehicles, movement, habitat, power management as well. And anything it's kind of like the catch-all bucket for technicians. So we talked about the training program next. Now, the training program for the astronauts, to list a few things, is just, I think, every applicant that goes through the process will have a certain set of expertise, but the minimum qualifications require, basic engineering technologies, basic medical skills, basic survival skills, learning how to use vehicle operations, specifically the rovers that we'll be using on Mars. EVA operation is fitness training. There's a minimum fitness level required, as well as more conflict resolution, interpersonal training, seeing as the applicants or the I guess astronauts will be collectively for a long duration period in a very small confined area with 4 or 5 other people. So these are the kind of the minimum training parts of the program. Next, we talk about the kind of the resources we need from the main station. So given the 160-pound male, someone like me, we're looking at approximately from fullspike.com, daily water chart, and approximately we're looking at 64 ounces of water per day, given a 5-day, in 5 days, we're looking at 320 ounces of water. And for 5 members, we're looking at 1,600 ounces of water. And this will all have to be produced locally on Mars. depending on the weight and size of your body. I guess you'll need plus or minus, but this is approximation for the sake of simplicity. For food, again, using the 160-pound male, we're looking at about, on average, 2,500 calories per day. And over 5 days, it's 12,500. And depending on members, you're looking at over 60,000 calories. Now, according to the food chart, food guide, you need your multiple food groups: grains, vegetable, fruits, fats, oils, milk, and meat. And the green and vegetable fruits can be grown on Mars. This will be part of, I guess, the greenhouse and our food production systems. However, milk, in quotes, dairy and meat will be unavailable, at least unavailable initially. And so we'll have to find ways to supplement the astronauts with proper nutrients. So I'm looking into calcium supplements and protein supplements and other potentially nutrient tablets that we can provide as a substitute for the lack of milk, dairy, and the lack of meat. So some guidelines to provide to other facilities from the main station. So the one thing we'll have to set in stone from the get-go is the rotating schedule for multiple chores, to say the least: kitchen duty, maintenance duty, sanitation duty, plant duty. Kitchen duty, we're talking about cooking, cleaning, but also the maintenance of it. Maintenance is the overall maintenance of the entire system, entire habitat, as the habitat will degrade over time. Sanitation, to keep things clean for hygiene. And then plant duty is to have people delegated to ensuring the food production plants, as well as the potential oxygen production plants, are not dying and they're actually healthy. Some mandatory activities that require every day: daily exercise. So in the 4th story of the Martian habitat, we have an exercise room. Ensure that everyone has their daily meals, and each daily meal meets all the nutrient requirements. And then hygiene primarily from the 4th floor of the Martian habitat, where there's the shower there as well. Some common activities to be used. It's important to have a well-balanced, work-life balance. So there's always going to be time allocated after work to spend together, and also time allocated for individual time. Some protocols I'll be listing out. The first protocol we're looking at, the 4 protocols I'll be talking about. Number 1 is the health and safety protocol. Number 2 is the entertainment protocols. Number 3, printing protocol. So the first and foremost, we talk about protocols of health and safety. So the first part of this is equipment. So since we're working in an environment where there's a lot of moving parts and definitely a lot of heavy machinery, PPE, or personal protective equipment, is made available to everyone. Furthermore, there's going to be clear instructions on how to handle the equipment, as well as proper training and recurring training for the equipment, whether that's the rover, whether that's the spacesuits, whether that's things as small as a bandsaw. There's going to be clear instructions and recurring training on using the equipment. As for processes for safety, we're looking at regular safety briefings. So this could be daily at the end of the day for debriefing at the beginning of the day. This could be a weekly summary, a monthly summary, depending on the amount of people. We'll have a specific safety procedures for common accidents and incidents. Things, for example, should somebody get hurt, there's procedures to follow that have been vetted out and triaged. And lastly, visual posters around for safety reminders to ensure that people are following these safety protocols. Last one we talk about is safety and health. Is regular physiological checkups. So with our medical doctor, there's going to be regular checkup, whether that's daily or weekly, as well as daily monitoring logs to be recorded by each astronaut every day. The second protocol to talk about is for the entertainment. And so one thing to keep the astronauts busy is physical activities. So we do provide equipment and room for individual and for team activities and sports. We have some more of the relaxed activities, so TV, movies, board games, and music, as well as important to include celebrations for common holidays like Christmas, birthdays for the individuals, and important to also capture milestones. For example, the 100 days, 200 days, so forth, or 1 year, and so forth. And so all these will kind of be overseen by everyone has a stake in this, but I think it will be the commander and the leads to be the ones to drive this protocol. A third protocol to talk about is for food production. So within our greenhouse, we'll have to have multiple food production. And the important thing is we have to require a variety of foods to provide complete nutrients to the people. So we need a few systems in place to ensure this happens. Number one, we have to have a system to produce fertile soil, which we'll have to be using a lot of compost. A system to foster plant reproduction, so we can reproduce plants at a positive growth rate. We have a system to detect and manage plant health, whether that's done via a robot or just even human monitoring. We have a system to harvest plants sustainably, so there's no food waste, everything is used correctly. And also, more importantly, due to the critical nature of the food production system, this is one of the critical parts of a manned mission, we'll have to have redundant systems, so buffer margins to ensure that we exceed the requirements needed. We have redundant systems in the food production area. We have potentially multiple cells, so if one cell fails, we don't lose all the food, and so forth. The last protocol to talk about is 3D printing. So 3D printing, because will be a huge part of how we create equipment and our day-to-day process, largely because whenever we need something, we don't have the ability to just have Amazon Prime shipping all the way to Mars. So 3D printing for day-to-day items, as simple as handles for doors, brackets, utensils, containers, things like that could be 3D printed. And more importantly, because we do have a limited amount of material, everything will be recycled. So a few processes we have to put in place is, number one, a collection system for all obsolete 3D printed items. So very similar to kind of how we do recycling right now on Earth. There'll be a system where if it's a 3D printed item made out of the plastics here, we can collect them. A process to then revert the items back into usable plastic filament. And lastly, then the 3D printing process can begin. So to kind of wrap up the main station, a few spin-offs to talk about. Technologies that can be applied to Earth. So I think because we need to really accelerate the 3D printing to ensure that we have sustainable habitat on Mars, 3D printing technology would probably be advanced quite a bit. The next point is developing stronger basalt-based concrete. So this could be used back on Earth for just stronger concrete in general. But the two main things I think is sustainable living and renewable resources, as well as research into human factors and psychology. So that first point, sustainable living, renewable resources, given that Mars is more or less barren, everything will have to be sustainable and everything will have to be renewable, which is not how we approach it on Earth right now. The second point, human factors and psychology. This is kind of an experiment that would be unparalleled, living on a distant planet, with 4 other people. This would provide a lot of research into how humans would react to loneliness, how humans react in close segregated areas, and so forth. So some guidelines to be applied daily Earth. Very similarly as the previous slide, it's mainly sustainable living and renewable resources. This would really advance the research we have on those two topics. And how it affects the global goals. On the same topic as the previous slide, there's a huge necessity to create sustainable cities and communities if we want to maintain, but also even if we want to expand the habitat. There's a necessity to create affordable and clean energy, using the same train of thought, if we want to maintain or expand. And more importantly, we need clean water and sanitation, given that there's no known sources of water on Mars, so we'll have to look into that. That wraps it up. Do I have any questions?